start the lecture. Then I'd like to talk about the group project. The group project. I will mention as much as I can about group project, and also I will go through each of the project, and I will try to explain it to you. And if you are interested in some of the project, and if you find something is not that clear, just stop me and ask me questions. All right, because it's a very good opportunity for me to introduce it to you, and for you to ask some questions to have a better understanding about each of the project. Because after that, you need to form your groups and choose your project for your group project in this subject. All right. So as I mentioned before, so it's a tough semester that we can't discuss together to do the project. Even if it is still called the group project, you can't discuss together or debug together face to face physically because of the social distancing, and also the robots and the sensors are not available to use. That is quite different from all the learning objectives I designed in this subject, because in the previous semesters, the students are really like using their robots. They really like using their robots. They learn a lot and they find a lot of fun by using the robot. But in this semester, we can't do that. I feel really sorry about that, but that is the case at the moment. I can't help too much on that. But what I can help is we, especially Marlene, helped to find out which robot we can use a robot simulator. And then we can use the simulator as similar to use the real robot. It is nearly similar as using the real robot. And then you have some experience about running a robot, and also you will feel difference, but you will not have some issues when using the real robot. There are a lot of issues when using the real robot. What we have before is like the sensors doesn't work, or they always need to like reinstall the Ubuntu on the robot, something like that. But you are not facing those kind of issues. And it's like the same. What you do on the simulator, you can definitely transform it into the real robot in the future. All right, and as I mentioned before, because the robots and the sensors are not available for this semester, then I need to revise the projects I have before, and I also need to delete some of them because we can't do that anymore. All right, so let's go through it one by one. All right, so before I go through the project one by one, I still want to mention something. The first thing is, because of these social distancing issues, I need to transform the final exam to the online exam. And we have a lot of meetings about how to do that. And I finally found that it is better to reduce the weight of the final exam and adding the weight of the group project. So it is not fully approved. So I didn't. I'm not talking about too much things on the deliverables of the fetch robot and also the weight of each of the deliverable. I'm not talking about that, but everything is finished. I've submitted it to the school and to the faculty for approval. But before the approval, I'm not talking about too much things on that, on the deliverables. All right. So just give you just give you a brief idea about how it changed. I'm going to change the weight of the group project to 50% and reduce the weight of the final exam to 30%. This is what I'm going to do. Sorry, any questions, any issues, just stop me, just ask me and stop me, right? Okay, so what I'm going to do is I'm going to enlarge the weight of the group project to 50% and reduce the weight of the online exam to 30%. All right, so this is not 100% confirmed, just giving you a brief idea about that. But I've finished everything already and I've submitted everything for approval. And then I'll let you know as soon as it is approved. Yes, so I've submitted the, sorry. Okay, so those are not confirmed yet, so I can't talk too much things on the final exam, but I mean, definitely the final exam will move to the online one. You're not going to take a physical one. I think this is the case in this semester. It's not fully approved, so I'm not saying too much on the final exam and also the deliverables of the group project. But I mean, just give you a brief idea about the how the weight changes for the group project. To give you have a better feeling about how much weight it has in the group project and how important is it, because it's 50%. If you get a full mark, and then you pass already, right? So that's the thing. And also subject offline. I've submitted changes of subject outline to the school already, and it's just waiting for approval, and then it will be updated later. All right, so I've submitted everything about changes, but it's just waiting for the approval. All right, so yeah, so because I changed the weight of the group project from 30% to 50%, it is more than 30%, then some of the deliverables I need to check it individually. For example, previously you are sending everything per group, but now I'm giving more deliverables for the group project with the certain deadlines and with the certain marks, with a certain weight, and someone is getting in the meeting room. And some of the deliverables I need you to submit individually. For example, for the previous semesters, what you need to do is you need to submit your selection of your group project, and you need to submit the proposal at the beginning, and you need to do the presentation in the very last lecture, and you also need to submit the final report. And all of them are in groups, so which means in each of the group you just need to submit one report, something like that, one final report, one proposal, something like that. But in this semester we will change. We will add in more detailed deliverables, more deliverables than the previous semesters. And for each of the deliverables, I'm giving a quite certain percentage of the weight. All right, and for each of the deliverables, and there's a hot deadline for that. And for some of the deliverables, it is submitted per group, and some of the deliverables you need to submit it. Why someone is keep joining the meeting? All right, so some of the deliverables you need to submit them individually. I mean, by each of the students, something like that. So I've finished everything. I finished everything in quite detailed ones, but I can't tell at the moment because it's not fully approved. I need to wait for the approval. It's more or less That's more or less not that kind of easy. It's not approved, but I need to wait for the option one. All right. All right. So I'm going to talk about the each of the deliverables, after it is approved, and I will release a much detailed documentation that you can have a look. All right. Then what I want to say is to let you have a better feeling about how the weight changes. Then because it's 50% on the group project, it's super important, super important. Try your best to make your group project finished excellent, and then you can have a very good result on that, very good mark on that, right? No, the project is not that even harder. So the project list is still there. So if you have looked already on the previous project list, I'm not changing each of the project inside. I mean, I changed only because some of the projects you can't use the robot anymore. Then you change the robot simulator, but the tasks are exactly the same. But I've changed the deliverables. And I've changed the deliverables by adding some of the deliverables and also making something in more details. And also some of the deliverables you need to submit by yourself. That's the thing. Okay, so as I mentioned before, so we don't suggest, in the previous methods, we don't suggest to do the project individually. It's better to form 2 or 3, better to be 3 people together to finish that project. But in this semester, because of the social distancing, so I will allow you, if you really want to work on the project yourself. It is okay for this semester if you really want to do that. And if you want to do that, please let me know. And the tasks, if you are doing it individually, which means you're doing the project only by yourself, I'm not reducing any of the tasks of the project. I'm not reducing any of the tasks in the project, which means if you want to do it individually by yourself, then you are doing the same thing as what the others do. What the others do for 2 or 3 people. All right. All right, cool, thanks. So again, so in this method, you are allowed to do it yourself if you really want. But I'm not changing the project itself for the individual group. Yes, definitely. So the group of 3 is what we suggested. Even we can't so the groups cannot meet face-to-face physically, but I still suggest each of the group has 3 students. Better to be 3, but if you really can't get 3, get 2. And if you really want to do it by yourself, you do it by yourself. All right, so the group of 3 students are really suggested, something like this. All right, so if all good, let's move to each of the project list. So first, we have 2 projects about fetch robot. And if you're doing fetch robot, if your project is pretty excellent, you have the chance to demo your work on the fetch robot to present present case in the future. For example, the UTS Open Day or something. Then you can represent case to present to demo your work on the real fetch robot. And for the fetch project, what we always do is we first develop everything on the simulator. I think you've seen the simulator before. So fetch has a very good simulator. It's like it's nearly the same as what you're using in the real case. That simulator is pretty good. And what we always do for the fetch robot is we develop everything on the simulator and we test it. If we have confidence on that, we move to the real robot. But in this semester, we can't move everything on the real robot anymore. So which means everything will be on the simulator. So if you're working on one of the two fetch robot projects, and everything will be on the fetch simulator. All right. So the first fetch robot project is fetch robot following the path. So which means there's a fetch robot and there will be a leader. So normally, if you have the robot, the people can be the leader. And then in the simulator, you can use anything. You can just use a marker or something in front as to simulate the people as the leader. And the target is to control the fetch robot to follow the leader or the guider in front. And it moves in the simulated environment and with a certain distance. So which means, suppose a person is the leader. If the person moves forward, the fetch robot will follow forward. And if the people move backward, then the robot will move backwards. All right. And then if the people turn left, and the robot will turn left as well. And all these kind of like functions, the robots need to keep a constant distance to the guider or to the leader. Then in this case, you can use any of the sensors on the robot. So you have the flexibility about using any of the sensors on the robot. So I can mention that to you. So on the robots, you have a odometry, which is the wheel encoder, to telling you the retro pose calculated from the wheel. Then you have a 2D laser scanner. It's on the bottom, on the base, on the mobile base of the robot. So you have a 2D laser that you can use as well. Then you have an RGB sensor on the head. You have an RGB camera on the head. You can only use depth image. You can only use the RGB image, or you can use both. So you can use any of the information you can get from the fetch robot to finish that task. And for fetch robot, I think you definitely need some skills about Linux, ROS, and C++ programming. All right, so any questions on the first project? All right, so again, so every project related to a real robot, so we are not doing anything on the real. So we are developing things on the simulator. All right. So the second project about fetch robot is fetch robot grasping. So which means you're doing some visual serving, you do some controlling on the robot arm and also the end effector to pick up some objects. And again, you can use any sensor you want, but mainly it is about the RGB, the camera on the head. You can use RGB or RGB depth, but I mean, using RGBD will be much easier for this case. And you can simulate some objects on the table and to control the fetch robot to pick up the object and put it back, or put it in another location, something like that. All right, and for this project, the minimum number of objects you're considering in this case, in this project is 2. So which means you need to consider at least 2 objects at the same time on the table, and the fetch robot can detect which one it's going to pick up. All right. So for example, if there's an orange, so if the two objects are orange and a Coke, and both of the two objects are on the table. And you need, suppose you tell the fetch robot, say you're picking up the Coke. Then the fetch robot can identify which object is Coke and pick it up correctly. All right, so at least two objects. And in this case, you're still doing everything in the fetch simulator, and again, you need it requires some skills in Linux, ROS, and C++ as well. And also, you need to know some basic functions about how to control the robot arm. But I mean, you just need to use the control of the end effector or robot arm as easy as possible. And there are some available functions there as well, APIs as well. So it's quite easy to use, and on my point of view. All right. So I think all good for the fetch projects, right? The fetch, two projects about fetch. Then we used to have 3 projects on the DoBot, but I've double checked the remote lab of the DoBot. It doesn't work at the moment, and also we don't have simulator on the DoBot. So I deleted all the three projects about using DoBot from this group project. And also, I delete one project by using the EM checking system, because we can't. I have the EM checking system. I have 2 of them, but none of them can be used anymore in this semester. This sit in the lab, we can't use it. So I've deleted 4 projects from them. So I apologize about that, but this is the case in this semester. Okay, so the next one with the next couple of projects are mainly about the turtlebots. So the first one is the turtlebot following a straight line. The turtlebots can following a straight line. And again, for all the projects about turtlebots, you're doing everything not on the real robot, but on the turtlebot simulator. All right. So the first turtlebot project is about the turtlebots following a straight line. So this is mainly about video serving and also some control about the mobile platform. Then if you are interested about that, I do suggest you to spend a little bit of time on the lecture notes of the video serving. So suppose you have some markers, or you have a square on the wall, right? And then you are designing a line which is perpendicular to that marker, and you need to control the turtlebot to following that line you defined by observing that marker or that square. So if you have a chance to look at the lecture notes of the video serving, so from 4 points of a square, then you can calculate the control, which is the velocities of the linear and angular velocities to control the robot or the camera to following that. All right. So what I mean is, so suppose you have a wall, or you have in the 3D space or on the ground, you have a marker which is perpendicular to the ground, and then you're defining a line based on that marker or that some kind of features. Then you need to control. I mean, the turtlebot, you need to make some control algorithms and also the video serving algorithms to control the robot itself automatically to following your designed line by observing the markers or the features you defined. Right? I'm quite open for you to use any of the markers. So I find some of the students, they use some kind of like color markers. Some of the students, they use QR code, which is not the first idea in my mind, which is not that mentioned in the description of this project, but I'm quite flexible with that. So any ideas about finishing that kind of task, I'm happy with that. All right, and also for the and also it's the same for the fetch robot project. So if you choose the fetch robot following the guide, then I'm happy for you to use any of the markers on the back of the people. That's totally fine. That's totally fine. I'm quite flexible and open for any of the ideas for finishing the task, but you need to finish the task. All right. So yeah. So this is the first Turtlebot project. And here I want to mention something about Turtlebot. So you can use both MATLAB and C++ in controlling the Turtlebot. The Turtlebot has some interface of both. But I find, I know some of the students, some of the groups in the previous semesters, they've used MATLAB. And some of them, they didn't find any issue about that. And then they have a left demo, which is quite good. And but I found some of the groups, they have some delay by using MATLAB instead of directly using C++. I mean, it's totally up to you. So you have the flexibility to choose any of the programming languages you're going to use, but you may face some problems by choosing different programmings, but you can figure it out yourself. I'm quite flexible and open to that as well. All right, so that is the first Turtlebot project. Then the next one is the Turtlebot following each other. So the target of that project is, suppose you have two Turtlebots. You have two Turtlebots, and the first one is the leader, and the second one is follower. Your control is mainly on the second one. It is nearly the same as what we have for the fetch robot following. Right, so you make some control or use some sensors. You're making some controls on the follower to follow the leader, of the Turtlebot. All right, and again, you can use any of the sensor on the Turtlebot. And by the way, there is an RGB sensor on the Turtlebot, RGB camera on the Turtlebot, and there is a rotating laser on the Turtlebot as well, and there's an odometry on the Turtlebot. So you can use any of them, and also you can put any of the markers on the leading Turtlebot. So I find some group they use a QR code on it, and I found some group they use some color markers, which is quite easy to detect in RGB. Then it's easy to calculate the distance as well. All right, so I'm quite flexible and quite open for the solutions, but the target is the follower is following the leader of the Turtlebot. And for the leader, you don't have to develop anything on that. What you need to do is you just need to manually control it, and the follower can follow the leader, and that is fine. That is totally fine. All right, and because in this semester we can't use the real robots, so in the previous semesters if you choose that, you've located two Turtlebots and you develop them on it. So that is a lot of fun. But in this semester you are not using the real robot anymore. Then which means you will do everything in a simulator. So if you find it difficult to simulate two Turtlebots in the simulator, then I do suggest you simulate the leader as anything you want, but make the function of the leader. Right, so you can simulate the leader as a box, as a pure marker, and that is totally fine. But it needs to be a leader. So you have the ability to control the motion of the leader you simulated, and the follower can follow. that is totally fine as well. All right, so this is the second project on the TurtleBot. Then the next project is about the visual serving of a handheld monocular camera. I think this is easier to do, even we don't have access to the cameras. So previously, you can just borrow a webcam from the mechatronics lab, and you can do this project. But now you need to do something different. And what you can do if you want to choose this project, what you can do is you can use the webcam on your laptop. So you can use that camera, and that camera is fixed, right? Then you can move the marker, or you can move the marker and to calculate the motions of the controls of the camera, which is for which direction you're going to move, which can move to the desired location of the camera. So I do suggest, if you want to choose any of the project about video serving, so have a quick look at the lecture notes about video serving on the ETS Online, and you have a better feeling about what you're going to do. And the video serving is mainly about calculating a control, which is the angular and the linear velocity of the camera, and that control moves the camera to the desired location of that camera, something like that. For example, if you want to use your webcam as the camera, and then you can put a marker, a square or something, or a checkboard or something on the wall, then you can take your laptop and move it to see what kind of control of the camera you calculated from the video serving algorithm. And by doing that, you need to visualize that control. For example, if there are 3 linear velocity, then you can display it in space, right? And you can, based on the visualization of the control, then you can move your camera, or you can move your laptop based on the direction it calculated, and to see if it's moving to the desired location of the camera, something like that. So this is about the video serving of a handheld monocular camera. I think most of you can do that, because I think all of us has a webcam on the laptop that you can use, or you can use a separate webcam as well if you want. So that's why I keep that project here, because the monocular camera is quite easy to be accessed. All right, and in this case, you can use either MATLAB or C++, and I'm quite happy with that. And you can use any of the image processing or feature extraction algorithms or methods to do the video serving. I'm quite open and happy to have different solutions on that. All right, but the thing is, we need to finish the targets or the aim of this project. All right, so that is group project 8. And the next project is exactly the same as what we have for the group 8, so for the previous project, but it's an RGB camera. So I do want to say something here, is because you're using an RGB camera, and the RGB cameras from the lab and from the mechatronics studio are not available. So you are choosing this project only if you have an RGB camera yourself. All right, so if you have an RGB camera yourself, you can choose, and if you want to work on this project, you can do that. Otherwise, don't choose it. Why I'm keeping that is I know some of you may have the RGB camera yourself, so that's why I keep that project there, but it doesn't mean all of you can choose that. Again, you are choosing this project only if you want to work on that project, and also only if you have an RGB camera yourself. All right. So the target is exactly the same. It's still like video serving of a handheld camera, but you are using a handheld RGB camera instead of use a RGB camera. So that's the difference between Project 8 and Project 9. And again, you are choosing this project only if you have an RGB camera yourself. Otherwise, don't choose that because we don't have RGB camera available here. All right, so the very last one is the 3D control and path planning for the surgical robotic catheter in the aorta-based ultrasound. So this one is a bit complicated. I still list it because I work on that project, but I didn't find very good solutions for the in the previous semesters. Excuse me. All right, so this project is mainly about to control a catheter robot in the aorta to do the transcatheter aortic valve replacement. If you remember, I'll show you some videos in the first lecture about what I did for that surgical robotics project. And this one is mainly about using the ultrasound image obtained inside the aorta to control the catheter robot, which following the center line of the aorta. So suppose you have aorta. Aorta is sometimes like a tube. Right, so I have the model of that, so you can use that. And then I have a lot of ultrasound image from the IVUS, intravascular ultrasound. So which is the transducer is on the tip of the catheter, and it gives you a cross section with some angles, cross section of the vessel wall. And the image, the center of the image is the center of the catheter tube. And you need to use those images to calculate a control of the catheter tube. And the target of that control is to make the catheter tube following the center line of the aorta. For example, if you control the catheter robot and it's quite close to the vessel wall, it will break the vessel wall and it will kill the people, right? So we are not aiming for that. We are avoiding that. So which means the best way of controlling the catheter robot is to following the center line of the aorta. And what you have is the image from the ultrasound, which is the cross section of the vessel wall. Again, for this project, you are only working on some data set. So there's no simulator, and I do have some experimental data sets that provided to you to use. But I can provide you the model of the aorta and also the ultrasound images, the real ultrasound images. You can work on that. But the thing is, there's no like real robot or robot simulator on this. And I should say it is a bit difficult as experience in the last couple of semesters. All right, so those are all the projects, and I've already uploaded this document to the ETS Online. It is in the group project, and the title is Group Project Autumn 2020. All right, so do use this one instead of using the previous one because some of the projects can't use that, and the deliverables have changed as well. All right, so I've uploaded already. So the next thing you need to do is form the group. So try to find the students and form the groups of 3 students, and choose at least two projects from the list, and post your selection on the discussion board. Let me double check. So I've created a Wait a minute. Wait a minute. I'm logging in the ETS online. Wait a minute. Where is it? Okay. Okay. So I think you can still see my my desktop, right? So the document I've shown you is in the assessment and group project. There we go. So this is the project list, group project list I mentioned, right? So don't look at the others, and just look at the autumn 2021. And for each of the group, you need to choose at least 2 projects on the list, because I'm not 100% like confirm that I will locate you your first choice. I've tried to do that. But it's not promised, because I don't want the students are working on most of the students are working on one project instead of the others. I want the students to work on every of the project, something like that. So do choose at least 2 projects, from the list, and make the order as what you prefer. And then I will try to locate you your first choice as I'll try to do that, but it's not promised. All right. So please form your group. And post your selections in the discussion board. So if you go to the discussion board, I've created a title called 2020 Autumn Group Project Selection. So post your group, the forming of your group, together with the choices, with at least 2 project choices, onto this by 6 p.m. this Friday. So I've mentioned it here already. So please leave your choice of project and the members as well, and in the group here before 6 p.m. the 10th of April. And then I will release the location the location of the projects to you on Monday. All right, so I'll let you know which project you are going to do on Monday. All right, so form your group, choose at least 2 of the projects from the list, and post it to here by 6 p.m. this Friday. And then I will let you know which project you are going to do on Monday. All right. So we do have lots of deliverables, but I'm not telling you it at the moment because it's not fully approved. All right. I'll let you know as soon as possible. But this is the task you are going to do now. All right. So form your group, choose the topics, choose the projects, and post it here in the discussion board before Friday evening. All right, so let's go back to the chart. Yes, there'll definitely be the tutorial videos. I will contact Marlene to see if he's going to. I think we are definitely going to put it on the ETS online. So I'll double check with Marlene about that. Yeah, so please talk to the students and form the groups. All right. So I think time is nearly about that. So in my plan is at last I will introduce the stereo camera one, but I think we don't have time on that. So I will definitely introduce the stereo camera one, and also the triangulation, the 3D and triangulation. And then we will talk about time-of-flight sensors in the next lecture. All right. So any questions about the group project? Any questions about that? No, we can't use the debug. We cannot. we cannot use the DoBot because the robot itself is not available, and there's no simulation on the DoBot, so we cannot use the DoBot anymore. So please look at the documents I uploaded to the group project in assessment, and then please look at the new one, the 2021, and then the project listed on that is what you can choose. All right, and oh, there's a DoBot simulation. There's DoBot simulation. Okay, so actually, so could you please send me together to Malin about the DoBot simulation? Is there any like README or like descriptions about that? Then we can figure it out. So Malin is at the moment he is trying to write the instructions about how to set up the simulators of both fetch and Turtlebot. And thank you, Asha. So please send it to me, and we will double check. So if we can do that, and we can do the DoBot project as well. All right. So please send it to me and Melina as soon as possible, and we can decide if we can do that or not. Thank you very much. All right. So any other questions about group project? The group project is quite important again, because it is 50%. It's 50% now. If you get a full mark, if you have a relatively good reason to get a full mark, then you pass the exam already. Sorry, if you pass the subject already, right? So it is quite a large weight, and for the previous semesters, the students are really enjoying the group projects, and hope you can enjoy the group project as well. All right, so if there's no questions, and let's move to Malin for the hand activities. Thank you so much.